Hello everyone, good morning. This is lecture number 21 of ODE. So in this class, we're going to start method of variation of parameters, right? So in this class, this is part 1. In next class, we'll see part 2 and then we'll mind of this method of variation of parameters, right? Okay. So if you haven't watched all the previous videos, please watch all the previous videos and come back to this video, right? This is lecture number 21. So you watch up to lecture number 1 to 20 and then come back to this video, right? And we have completed, so far I completed 3 topics. The first is, in fact, 4 topics. The first is solving the differential equations of first order and first degree. Second is second and higher order linear differential equations, constant coefficients. Third is Cauchy-Euler equations. Fourth is Legendre linear equation, right? Now in this class, we're going to see method of variation of parameters, right? So again, it is very easy. You just have to understand the procedure. That is, you have to understand the working rule. If you understand the working rule, then you can do any problem, right? Super. Now, when to use method of variation of parameters? In question itself, they will say solve by method of variation of parameters, right? If you just recall what we seen in second and higher order linear differential equation, we have classified them into 6 types, right? Type 0 is RHS is 0. Type 1 is RHS is e power x. Type 2 is RHS is sin ax or cos ax. And then e power ax into b, polynomial in x. We have classified them into 6 types, right? If it does not fall under any of these types, use method of variation of parameters. For example, if your RHS is tan ax, right? If your RHS is tan ax, it doesn't fall under any type, right? Type 0, type 1, type 2, type 3, type 4, type 5, it doesn't fall under any types. If your RHS is sin tan ax, secant ax, cosecant ax, you can see it doesn't fall under any of the types, right? So in that case, we're going to use method of variation of parameters, right? You can also solve all the previous methods. That is, you can also solve second and higher order linear differential equations, Cauchy-Euler equations. You can also solve all these equations by this method also, right? This one also powerful method. Now you will see it is very easy, right? Okay. So first I will do the working rule and then we'll straight away get into the problem, right? We're going to do 10 problems today based on method of variation of parameters. First we will do the working rule, right? Okay. So I'll write down the working rule. Working rule. So working rule for solving d square y by dx square plus p into dy by dx plus qy is equal to r by variation of parameters by variation of parameters, just a minute, by variation of parameters right. Are we going to solve this equation, right? Working rule for solving d square by dx square plus p dy by dx plus qy is equal to r by variation of parameters where this p q r are functions of x or it can be constant also. This r can be anything, right? For example, it can be tan ax, secant ax, cosecant ax, right? If it is sin ax means you can solve by type 2, right? If it is x square means you can solve by type 3. If it is e power ax into sin ax means you can solve by type 4. But here, suppose if you have cosecant ax, tan ax, right? Whatever r may be, you can solve by variation of parameters. Is it clear? Right? Is it clear, right? Whatever the r may be, right? Whatever r may be, you can solve by variation of parameters. That means you can also solve all the previous methods by this method also. Right? This is one powerful method. Okay. By variation of parameters where p, q, r are functions of x are constants, right? So there are 3 steps to find the solution. So step 1. So step 1 is rewrite Very easy, right? Rewrite the given equation. Rewrite the given equation as y2 plus py1 plus qy is equal to r, right? Both are same only, right? Y2 means d square by dx square, y1 means dy by dx. Y2 means second order derivative, y1 is first order derivative, right? You make sure you rewrite this equation, right? Okay. Now step 2, right? Step 2 is consider y2 plus py1 plus qy is equal to 0, right? Which is obtained by taking r is equal to 0. Which is obtained by taking r is equal to 0 in 1, right? Let's call this as equation number 2 and solve 2, right? And solve 2 by previous methods, right? You know how to solve this equation, right? RHS is 0, it falls under type 0. That means the solution is y is equal to CF alone. We don't have particular integral here because RHS is 0. Solve 2 by previous method. By previous methods, right? You know how to solve the second order equations, right? Okay. By previous methods, right? Let the general solution of 2 be. So what will be the general solution? Y is equal to CF, right? Because we don't have anything in the RHS, right? Because we are finding the solution of this equation, which is 2. So let us write that CF as C1u plus C2v, right? You write in this pattern, right? Find characteristic function. It will be in this pattern only, right? For example, if your roots are real and distinct, means we will have C1 e power m1x plus C2 e power m2x. So here u and v are e power m1x and e power m2x, right? You can always write CF in this pattern where u and v are functions of x, right? Now what is the first step? Whatever r may be, first you find the CF, right? Method of finding CF is very easy. You just put r to be equal to 0, solve this equation. You will have two roots. So based upon the nature of roots, you find the CF, and from CF you write in this pattern, right? Write the CF as C1u plus C2v. U and v you have to find based on the problem. Okay. Now step 3. The general solution of 1, right? 1 is the required equation we need to solve, right? Is given by y is equal to CF plus PI, right? Where we need to find PI, right? Where PI is equal to, I'm going to write in the formula, which is u into f of x plus b into g of x, right? Here all 4 are unknowns, but u and v you can find from characteristic function, but we don't know what is f of x and g of x, right? Where f of x is minus integration of b into r by w dx, right? B is we can obtain from characteristic function, r is the RHS part, w I'm going to tell what is w, and g of x is integration of ur by w dx, right? Where w is the Wronskian of u and v, right? W is the Wronskian of u and v. Very easy, right? I'll define what is the Wronskian of two function. Wronskian of u and v. So that is determinant of u, v, u dash, v dash, right? So expand this determinant, you will get w. Expand this determinant, you will get w. That's it, right? So this is general solution, right? So therefore the general solution is very simple. If you understand the single slide, you can do any problem. CF plus PI, right? So very easy. Working rule for solving this equation by variation of parameters, right? Where this P, Q, R all are functions of x, or it can be constant also. If it is a function of x, it will be a Cauchy-Euler equation. If it is constant, means it will be a second order linear equation, constant coefficients, right? Now what you have to do? Very simple. put r is equal to 0, find the characteristic function, write the characteristic function as c1u plus c2v, obtain u and v, right? After obtaining u and v, just write u and v separately. Now what is general solution? Cf plus pi. Cf we already found. What is formula for partial integral? U f of x plus b g of x. U and v we already know from Cf. What is f of x? Minus integration of vr by w dx. G of x is integration of ur by w dx. These w, v, r. V we can obtain from Cf. R is the RHS of a question. W is the dot scale of u and v. We have to make use of this formula, right? Determinant of u, v, u dash, v dash. Expand this determinant, you will get the value of w. Substitute back w here. Find f of x and g of x and substitute in pi. Add Cf and pi. You will get the required solution. Is it clear? Is the slide is clear? If I do one problem, you can do any problem, right? We are going to 10 problems today, right? Very, very simple problem. So you just have to follow these 3 steps to find a solution. That's it. Is there any doubt up to now? Very important, right? Very important exam point of view. Whatever RHS may be, you can solve by variation of parameters. But in the previous cases, you have classified type 0, type 1, type 2, type 3, type 4, type 5. If your RHS doesn't fall under any of the types, for example, tan AX, cosecant AX, right? You use variation of parameters. Okay. How to solve? Put R is equal to 0, find Cf, write Cf as C1U plus C2V, right? U and V, you have to find depending upon the question. After that, what is formula for Pi? Very important. This is a formula for Pi, right? U f of x plus b g of x. U and V already know from Cf. Find f of x and g of x using this formula. Find W, which is a Wronskian of U and V, right? Okay. That's it, right? We're going to do some problems. So we're going to solve every method by variation. We're going to solve every problem by variation of parameters only, right? Okay. To solve y2 plus n square y is equal to secant nx. So you can see it doesn't fall under any one of the types, right? If it is sin nx means you can easily do by type 2. If it is cos nx means you can also do by type 2, right? Replace d square by minus of a square and so on. But here we have secant nx, so we'll use method of variation of parameters, right? Very, very simple. We do this fast. Okay, solution. So this is same as d square by dx square. This is same as d square y by dx square plus n square y is equal to secant nx, right? Both are same. Both are same only. Okay. So what is this equation is same as d square plus n square of y is equal to secant nx, where d is d by dx, right? Okay. Now what is the step 1? Step 1 is you put r is equal to 0, right? You put r is equal to 0. So that is consider this equation r is equal to 0. So obtained by taking r is equal to 0 and solve this equation, right? So consider d square plus n square of y is equal to 0. Whatever r may be, here r is secant nx, and here there is no p term here, right? There is no p term here. That is, there is no first order derivative. We have this term and this term. This term p is 0 here. Okay. So solve this equation. What is the auxiliary equation? This m square plus n square is equal to 0. That means m square is equal to minus n square. So m is equal to plus or minus ni, right? So that means the roots are one pair of complex root. So your CF is e power alpha x. Here you always write everything in terms of x. So because the independent variable is x only here. So e power alpha x, c1 cos beta x plus c2 sin beta x. This is 1. So your CF is c1 cos nx plus c2 sin nx, right? This is your CF. So we are done with CF, right? We are done with CF, right? The solution is CF plus PI. You are done CF, right? Okay. So from CF you obtain u and v, right? Write CF as c1u plus c2v. That means here what is u? U is cos nx, v is sin nx, right? This is your u and v. That is what I said is you find CF by putting r is equal to 0 here. That is solution also. You write that as c1u plus c2v. So u is cos nx, v is sin nx, right? That's it. Now we will find particular integral. So for particular integral, what is formula? U f of x plus v g of x, right? Before that, we'll find Ranskin, right? Before that, we'll find Ranskin. So what is the Ranskin here? Ranskin is given by u v u dash v dash, because we need this w to find f of x and g of x, right? So the integration, the determinant of cos nx sin nx, cos nx sin nx, cos nx sin nx, u dash, differentiate this, minus sin nx into n. This is cos nx into n. Differentiate this, right? So if I expand this determinant, we will have n into cos square nx plus n into sin square nx. So if we take n outside, we will have sin square nx plus cos square nx, which is n, right? So we will have cos square nx plus sin square nx is 1, right? So we will have n is your w. Now what is your pi? Here what is your particular integral? U into f of x, u into f of x plus b into g of x, right? We already know u and b because u is cos nx, b is sin nx, right? Now find the f of x and g of x. Now what is f of x? Minus integration of bw by, sorry, br by w. br by w, right? This is your br by w. So minus integration of, what is b? b is sin nx divided by, into r, right? What is r? R is secant nx by w. So w is n, right? W is n. Now you have to integrate this dx. So minus 1 by n integration of sin nx. I can write the secant nx as 1 by cos nx, right? Secant nx is 1 by cos nx. And very simple, right? F of x, f dash of x. So I can write this as 1 by n integration of minus sin nx by cos nx. So f of x, f dash of x. So we know, right, integration of f dash of x by f of x is log f of x. So cos n, if I differentiate cos nx, it will be minus sin nx into n. But n is missing here, right? So what we'll do is we'll multiply 1 n and multiply by 1, divide by 1 n. Now you can see f of x, f dash of x, right? Cos nx derivative is minus sin nx into n. This means 1 by n square will be here. This is log of cos nx, right? You take f of x to be cos nx. That's it. This is your f of x now. Now you find g of x. G of x is integration of ur by w dx. So 1 by, so w is n, integration of u into r. So u is cos nx, r is secant nx, right? Dx. Now you have to integrate this. This will be 1 by n integration of, I can write secant nx as 1 by cos nx, right? Dx. So this will get cancelled. So integration of dx is x. So we will have x by n. This is your partial integral. And this one g of x. So therefore pa is u into f of x. Pa is u into f of x. U into f of x plus b into g of x. So what is u? U is cos nx. Cos nx into f of x. So f of x is 1 by n square log of cos nx plus b is sin nx, g of x is x by n. This is a particular integral. So therefore, general solution is it clear? Y is equal to cf plus pi. So cf is c1 cos nx plus c2 sin nx plus particular integral is cos nx into 1 by n square log of cos nx plus sin nx into x by n. Is it clear? Very, very simple, right? You just have to remember this single slide to do all the problem. right? So we have solved y. Now from this I'm going to give you 3 problem for exercise, right? 1, 2, 3, right? So second problem is d square y. Is it clear? Very easy, right? y2 plus y is equal to secant x. y2 plus 4y is equal to secant 2x. y2 plus 9y is equal to secant 3x. If these 3 questions are asked, we already know, we already solved, right? We already solved y2 plus n square y is equal to secant nx, right? And we already know solution is, this is a solution, right? So here put n is equal to 1, right? These 3 questions are asked, put n is equal to 2 here, put n is equal to 3 here. So that means if these 3 questions are asked, what you have to do means, in general, you find the solution for this, right? Or else you can also very easily, right? Wherever n, you put n to be 1 here, n to be 2 here, n to be 3 here. Or you find a solution for this question, which is, this is solution, right? This is solution. In this solution, put n is equal to 1. You will have solution for this question. In this solution, put n is equal to 2. You will have solution for this question. Put n is equal to 3 in the solution. You will have put n is equal to 1, 2, 3 in the previous solution. Is it clear? Put n is equal to 1, 2, 3 in the previous solution. And you want the next problem? See, from first question itself, you can do these 3 problems, right? Okay. Instead of 1, 2, 3, I let A, B, C. Now move on to second problem, right? Okay. Clear, right? Second problem. Solve y2 plus a square y is equal to cosecant ax. So in the previous problem, we have secant ax. So in here we have n, here we have a, right? That is not a problem. Here in the previous one, we have secant nx. Here we have cosecant ax, right? So we will solve. So we'll do this quickly. So solution. So first, what you have to do, put r is equal to 0. So we have consider y2 plus a square y is equal to 0. This is same as d square plus a square of y is equal to 0. So your auxiliary equation is m square plus a square is equal to 0. So m is equal to plus or minus ai. So therefore, your characteristic function is e power alpha x c1 cos beta x c2 sin beta x. So your CF is c1 cos ax plus c2 sin ax, right? There in the previous one we have cos nx sin nx. So what is your u here? So u is cos ax. What is your v? V is sin ax. And what about your Ranskin? Ranskin is uv u dash b dash. So this is cos ax. Derivative of cos ax is a into minus sin ax. So sin ax, this is cos ax into a. So we will have a cos square ax plus a sin square ax. Expands determinant, right? So take a outside, you will have 1. So a is your Ranskin, right? So therefore, what is your particular integral? U into f of x, u into f of x plus b into g of x. We know u and b, or we know f of x and g of x. So f of x is minus integration of dr by w dx minus integration of what is b? B is sin ax into r. R is cosecant ax, right? R is your RHS divided by W. So W is A dx. So I can take this 1 by A outside. This is sin AX. I can write cosecant AX as 1 by sin AX dx. So again, these two will get cancelled. So integration of dx is x. So we will have minus x by A is your f of x. Now g of x is integration of ur by w. So here we have minus, we don't have minus here. So integration of u is cos AX, r is cosecant AX divided by w. So w is A. So I can write this as 1 by A integration of cos AX by cosecant AX is sin AX, right? 1 by sin AX. So differentiation of sin AX is cos AX into A, right? Differentiation of sin AX is cos AX into A. So what we will do is we will multiply and divide by A. So therefore this is log, this integration is log of sin AX, right? So integration of f dash of x by f of x is log f of x. So f of x is sin ax. So therefore 1 by a square sin ax. 1 by a square sin ax is your f of x, sorry, g of x. Therefore your pa is u into f of x plus v into g of x. So u is cos ax into f of x. So f of x is minus x by a. V is sin ax into g of x is 1 by a square log sin ax. This is your pi. Therefore, the general solution is y is equal to cf plus pi. So cf is c1 cos ax plus c2 sin ax plus pi is minus x by a cos ax plus 1 by a square sin ax log of sin ax, right? This is your general solution. That's it, right? So I'll give you some exercise problem based on this problem. Y2 plus y is equal to cosecant ax, cosecant x. B y2 plus 9y is equal to cosecant 3x, right? So here put a is equal to 1 in this solution. You will find solution for this problem. Put a is equal to 3 in previous solutions, right? In general, you solve this. You put a is equal to 1 here. Here you put a is equal to 1. You will have solution for this problem, right? C1 cos x plus C2 sin x minus x cos x plus sin x log sin x. That will be a solution for this problem. Put a is equal to 3. That will be a solution for this problem, right? Yes. So we'll move on to third problem. Okay, very, very easy problem, right? And also very important also. Everything is clear, right? Third is solve y2 plus a square y is equal to tan ax. Tan ax, right? See, we are generalizing all the problems, right? 1, 2, 3 are generalizations. Here we have in all three terms your p is 0, right? Because we don't have the first order derivative. This is d square by dx square, and in this only y. Okay. Here we have secant nx. We have generalized that, and we have cosecant ax. We have generalized that. Remember here a square. It has to be in that pattern, right? Here also you can see a square. In that, it has to be in that pattern. And again you can see tan ax, right? So in the first problem we have secant ax. Previous problem we have cosecant ax. Now we are going to tan ax, right? So we will solve this. So consider this equation, right? y2 plus a square y is equal to 0. So the auxiliary equation is m square plus a square is equal to 0. That means m is equal to plus or minus ai. Therefore, our CF is C1 cos ax plus c2 sin ax. So therefore your u is cos ax and your b is sin ax. And what about the Wronskian of u and v? So it is cos ax, derivative of cos ax is minus sin ax into a. B is sin ax. This is derivative is cos ax into a. Again, you will have only a, right? A cos square ax plus a sin square ax, which will be 1. So a is your Wronskian. Now, what is your particular integral? U into f of x plus b into g of x. Now we will find f of x. F of x is minus integration of dr by w. So what is b? B is sin ax into what is r? R is tan ax divided by w. W is a, right? W is a. So this is minus 1 by a integration of sin ax. Tan ax is sin ax by cos ax dx. This is minus 1 by a integration of sin square ax by cos ax dx, right? So how to integrate this? So we know sin square ax plus cos square ax is 1. So I'm going to write this as minus 1 by a integration of 1 minus cos square ax by cos ax dx, right? So sin square ax plus cos square ax is 1. Therefore, I can write cos square ax as, sorry, I can write sin square ax as 1 minus cos square ax, right? Now, divide this separately. So, we will have integration of 1 by cos ax dx minus integration of cos square ax by cos ax dx. This will be minus 1 by a integration of secant ax, right? You know this formula, dx minus integration of cos ax dx. Now, this is what is the formula of secant dx? What is the integration of secant x? Secant x plus log of secant x plus tan x, right? So, but we have ax, so you will differentiate, we will have a. So, 1 by a log of secant ax plus tan ax. Very simple, right? I already listed all the formulas. The integration of secant x is log secant x plus tan x. Here we have ax, differentiate that and put it in the denominator. So, we will have 1 by a log of secant x plus tan ax. And what about integration of cos ax? Sin ax by a, right? Now if you multiply this 1 by a inside, this will be negative, this will be positive. So write this positive term first. So we'll have 1 by a square sin ax minus 1 by a square log of secant ax plus tan ax. This is your f of x. Now what is your g of x? G of x is integration of ur by w dx. So integration of u into r. So u is cos ax into r. R is tan ax divided by w. W is a. So 1 by a integration of cos ax. Tan is sin ax by cos ax dx. These two will get cancelled. So integration of sin ax is minus cos ax by a. So minus 1 by a square cos ax is your g of x. Therefore, your pi is u into f of x plus v into g of x. What is u? U is cos ax. F of x is 1 by a square sin ax minus 1 by a square log of secant ax plus tan ax plus b sin ax into g of x is minus 1 by a square cos ax. This is a partial integral. Therefore, the general solution is y is equal to cf plus pi. So you know what is cf, right? This is your cf and this is your pi. So add it up. You just add it up to get the particular integral, right? Now exercise. So based on this, you have to y2 plus y is equal to tan x. So y2 means d square by dx square, right? y2 plus 4y is equal to tan 2x, right? So here put a is equal to 1, put a is equal to 2 in previous solution to find the answer. Right? In the example, this question was asked, you can either you can either say in general, first we will find the solution for dy2 plus a square y is equal to tan x. So, solve this problem. In the above solution, you put a is equal to 1 to get the required problem. Or you can also directly solve this by putting a is equal to 1 also, right? That is your wish. Okay, so we have solved three problems, right? All three are like problem. The only thing is in the RHS, here we have secant nx, here we have cosecant ax, and here we have tan ax. So move on to fourth problem now. Cot ax now. Now we are going to solve fourth problem. Solve. But in all four problems, your p is 0. That is the first order derivative coefficient is 0. Solve y2 plus a square y is equal to cot ax. Right? So we'll do this. We'll do fast. So consider y2 plus a square y is equal to 0. So this is same as d square y by dx square plus a square y is equal to 0. All are same only, right? This is d square of a square of y is equal to 0. See, in exam point of view, this y2 can be d square by dx square, right? Or it can also be like capital D. All are alike only, right? Don't get confused. All three are alike only. This. Okay. Now, what is your auxiliary equation? It is plus or minus a is your characteristic function. It's the roots. So CF is C1 cos AX plus C2 sin AX. Now your U is cos AX and your B is sin AX. Find the Ranskin. So it is UB, U dash, B dash. Again, you're going to get what? A only, right? Now, what is your partial integral? U into f of x plus b into g of x. This is your particular integral. Now we'll find f of x minus integration of dr by w minus integration of what is b? B is sin ax. What is r? Cot ax divided by w is a. So minus 1 by a. Forgetting put dx, right? So always put dx when you have integration. So integration of sin ax, cot ax is cos ax by sin ax dx. So this is minus 1 by a integration of cos ax plus sin ax by a, right? Sin ax by a. So minus 1 by a square sin ax is your f of x. Now you find g of x, integration of ur by w. So integration of u is cos ax, r is cot ax divided by w is a. So 1 by a, see you have to put dx, right? 1 by a integration of cos ax, this is cos ax by sin ax dx, right? Because cot is cos by sin. So 1 by a integration of cos square ax by sin ax dx. So again I'm going to write cos square ax as 1 minus sin square ax by sin ax dx. Now this is 1 by a. So if I integrate, if I divide separately, we will have 1 by sin ax minus integration of sin ax dx, right? So 1 by sin ax, and if we divide this, one sign will get cancelled. So 1 by a integration of cosecant ax dx, integration of sin ax dx. So 1 by a, what about cosecant ax? What is the integration of cosecant ax? It is log of tan x by 2, right? Actually, there are many formulas for cosecant ax, integration of cosecant ax. We have written, we already know, right? As Actually, there are many formulas for this, for cosecant. Actually, there are four similar formulas. So integration of, what is integration of cosecant x dx? It is minus log cosecant x plus cot x, right? This is the one that I have wrote early in the previous classes, right? Cosecant x minus log cosecant x plus cot x. Or you can also write this to be log of tan x by 2, right? Both are same, all are same only, right? All are same only. Actually, there are four formulas, right? Or you can also write this as log of cosecant x minus cot x, or minus log of cosecant x plus cot x. All are same only, right? Minus log of cosecant x plus cot x. So there are three formulas for integration of cosecant x dx. Actually, there is also one more formula, that 1 by 2 log of cos x minus 1 by cos x plus 1, but no problem, right? So you can write integration of cosecant x to be this, or any, right? Okay. So you can use any one of these three formulas here. Integration of cosecant dx, but in the book they have used this formula, that is log of tan x by 2. So I'm going to use this formula, right? There are three formulas for integration of cosecant x. So if I use this formula, it will be log, instead of x we have ax, right? So log of tan ax by 2, log of tan ax by 2. To differentiate this, we will have a, so I'll put 1 by a. And integration of sin ax is minus cos ax by a, right? So that's it. This is the value of your f of x. So if I take this, this is plus, right? So if you multiply this a inside, we will have 1 by a square. Let us take this 1 by a outside here, right? This 1 by a and this 1 by a. So we will have log of tan ax by 2 plus cos ax. This is your g of x. Therefore, your PA is u into f of x plus b into g of x. See, you can write integration of cosecant x ax to be any one of these three formulas: log of cosecant x minus cot x, or minus log cosecant x plus cot x, or log of tan x by 2. You can use any one of these in the exam point of view. But in the book they have used this formula, so I'm writing this formula, right? Okay. You can also use this any one of those. So u into f of x. So u is cos ax. F of x is 1 minus 1 by a square sin ax. B is sin ax. G of x is this entire term, 1 by a square log of tan ax by 2 plus cos ax. This is your pi. So therefore, the general solution is y is equal to cf plus pi. Write it down, right? This is your cf, c1 cos ax plus c2 sin ax, and the pi is this entire term to find solution, right? Exercise. So based on this, I'm going to give you formulas, problems. So solve y2 plus 4y is equal to cot 2x. y2 plus 9y is equal to cot 3x, right? So here put n is equal to 2, put a is equal to 3, right? Put a is equal to 2, a is equal to 3 in previous problem. Right. Okay, so we want fifth problem now. To solve y2 plus 4y is equal to 4 times tan 2x. See, this is different from the one, because here we have 4 here. So that means it doesn't fall into this category, right? So ax a square, but here we have some coefficient here. That means you cannot put a is equal to 2 in the solution to get that answer. So you need to solve separately for this problem, right? Because we have some coefficient here. Okay, so we'll do this. I'm going to do this very fast, right? So consider y2 plus 4y is equal to 0. That means we have d square plus 4 of y is equal to 0. What is d? D is d by dx. So we have m to be equal to plus or minus 2i. So your CF is C1 cos 2x plus C2 sin 2x, right? So therefore, your U is cos 2x and your V is sin 2x. What about your Ranskin? U dash, V dash. So this is determinant of cos 2x. This is minus sin 2x into 2. Sin 2x is cos 2x into 2. So you will have 2 into 1. So 2 is your Ranskin, right? So 2 cos square 2x plus 2 sin square 2x. So what is your PI? So PI is u into f of x plus b into g of x, right? U into f of x, b into g of x. So find f of x now. F of x is minus integration of VR by W minus integration of V. So what is V? V is sin 2x. R is 4 tan 2x, right? I'll take that 4 outside. Divided by W. W is 2. So 2 ones are 2 twos are. So minus 2 times integration of sin 2x. And tan 2x is sin 2x by cos 2x. Right? Sin 2x by cos 2x. This is minus 2 times integration of sin square 2x by cos 2x dx. And the sin square is, I can write sin square 2x as 1 minus cos square 2x divided by cos 2x dx. So divide separately. So 1 by cos 2x is integration of secant 2x dx, right? 1 by cos 2x dx integration secant 2x, and 1 cos will get cancelled. We will have integration of cos 2x dx. So minus 2 times. So integration of this is 1 by 2 log of secant x plus tan x, secant 2x plus tan 2x, and this is minus sin 2x by 2, right? You can also take this, you can also cancel this 2, right? Okay, so therefore, you can cancel this 2. If we take this minus inside, this will be plus. So sin 2x minus log of secant 2x plus tan 2x is your f of x. Now similarly, you find g of x, integration of ur by w dx, integration of u is cos 2x, r is tan 2x divided by w is 2 dx. This is 1 by 2 integration of cos 2x. This is sin 2x by cos 2x dx. So integration of sin 2x is minus cos 2x by 2. So minus 1 by minus cos 2x by 2, right? So minus 1 by 4 cos 2x. So minus 1 by 4 cos 2x is your okay, I think I missed 4, right? So r is 4 times tan 2x, right? So let us multiply 4. So get cancel. So minus cos 2x, because r is 4 tan 2x, right? R is okay. So therefore, your PI is u into f of x plus p into g of x. Substitute back here. So therefore, general solution is y is equal to pf plus pi, right? So find, substitute f of x and g of x here and add it up to find the solution. Very easy, right? Is it clear up to now? Can I move 6th problem? To solve y2 minus y is equal to 2 divided by 1 plus e power x, right? Very, very interesting problem. You can see it doesn't fall under any of the types, right? Type 0, type 1, type 2, and so on. Okay. So we'll solve this, right? Solution. So I'll do this a little bit fast, assuming that you are comfortable now, right? So put this r just to be 0. So we have y2 minus y is equal to 0. This is same as d square minus 1 of y is equal to 0. So that means your auxiliary equation is, what's the solution? M is equal to m square minus 1 is 0. So m is equal to plus or minus 1, right? Therefore, your CF is C1 e power x, C2 e power minus x. Right? Now, in this problem, your u is bx, e power x, b is e power minus x. Right? In previous problem, your u is sin ax, cos ax, but here u is e power x, b is e power minus x, right? Because C1 u plus C2 b. Okay. Now, find the Wronskian. U dash b dash. So this is e power x, derivative is e power x again. B e power minus x, derivative is minus e power minus x. This will be minus of, so e power x into e power minus x. And here we have minus e power x into e power minus x. So this will be e power 0 minus e power 0, right? Because e power x minus x, e power x minus x. So minus 2 is your Wronskian, right? Minus 2 is your Wronskian. Now what is your particular integral? U into f of x plus e into g of x. Now we'll find f of x and g of x. Now what is your f of x? Integration of minus dr by w dx. So integration of v into r. So what is v? V is e power minus x, into r. So w is 2, r is 2 divided by 1 plus e power x. So we have minus integration of 1 by e power x plus 1 e power x dx, right? So we have minus integration of, okay, this is minus 2, w is minus 2, right? So this will become plus. So you have to integrate this, right? Integration of e power x, integration of 1 by e power x plus 1 plus e power x dx, right? We have to integrate this. How to integrate this? Very easy. Yes, how to integrate this? Put x is equal to e power z, right? So therefore, differentiate with respect to z. So we will have dx by dz is equal to e power z. That means your dx is zero. Okay, we will differentiate with respect to x. Differentiate with respect to x, right? So we will have 1 is equal to e power z dz by dx. Therefore, your dx is e power z dz, right? E power dz is e power x, dz is we need even dx, right? Okay, dx is e power z dz. Dx is e power z into dz, and we know e power z is x, so dz is x dz. Therefore, integration of 1 by z into 1 plus z, and what is dx? Dx is, wait a minute. I think we are doing mistake. Dx is e power z dz. So we have e power x okay, sorry, we have e power x, right? Sorry, e power z, sorry. Just a minute. That is the problem if we do fast. Okay. So we have e power x, right? So put e power x is equal to z, right? E power x is equal to z. Therefore, differentiate with respect to x, or you can also differentiate with respect to z also. Yes, e power x dx by dz is equal to 1, right? And differentiate with respect to z. So therefore, e power x dx is dz. So we have dx to be dz by e power x, and we know e power x is z. So I can write dx as dz by z. Right? So now we converted everything in terms of z. This integration of 1 by z square into 1 plus z dz. Now you know how to integrate this, right? Do partial fraction and integrate. So consider 1 by z square into 1 plus z. What is your partial fraction? How you write? So a by 1 plus z for this distinct root. We have b by z plus c by z square. Right? This is how you write partial fraction. We all done this. Now find ABC. So multiply by z square into 1 plus z throughout. So we have 1 is equal to a into z square plus b into z into 1 plus z, c into 1 plus z. Now put z is equal to 0. So we will have 1 is equal to a will be 0, b will be 0, c will be 1. Now put z is equal to minus 1. So we have 1 is equal to minus 1 square is 1, 1 into a, b and c will be 0. Right? Now equate z square coefficients. So here there is no z square. Here we have a and here we have b. So a plus b is 0. So we have b is equal to minus a, which is minus 1. Right? So therefore, integration of 1 by z square into 1 plus z dz is equal to integration of a by 1 plus z plus b by z plus c by z square dz. Now what is a? A is 1. So integration of 1 by 1 plus z dz. What is b? b is minus 1 minus 1 by the dz. C is 1. Right? So therefore, this will be integration of this is log of 1 plus z. This is log z. And what about this term? This is same as integration of z power minus 2 dz. So log of 1 plus z minus log z. Z power minus 2 plus 1 by minus 2 plus 1. So we will have minus 1 by z, right? Minus 2 plus 1. Z power minus 1 by minus 1. Yes. Now you replace z to be what is z? E power x. So 1 plus e power x minus log e power x minus 1 by e power x. So log of 1 plus e power x. This will be x, right? This will be minus e power x. This is your f of x. Now find g of x. G of x is integration of ur by w dx. So integration of u. What is u? U is e power x, right? E power x. What is r? 2 by 1 plus e power x. W, right? W is minus 2, right? Okay. So these two will get cancelled. So we have minus integration of e power x by 1 plus e power x, right? Now we can see f of x, f dash of x, right? F of x, f dash of x. Therefore, this is minus log of 1 plus e power x. That's it. It is of the form integration of f dash of x by f of x dx. It is log f of x, right? So this is your g of x. So therefore, your particular integral is u into f of x plus b into g of x. What is u? U is e power x. F of x is log of 1 plus e power x minus x minus e power minus x plus b into g of x. This is a particular integral. So therefore, the general solution is y is equal to cf plus pi. Now add it up to get the solution, right? Is it clear? So we want to solve the problem. To solve, y2 minus 3y1 plus 2y is equal to e power x divided by 1 plus e power x, right? Now in the first time we are having this term to be non-zero. In all previous cases we have y2 term and y term, right? Yes, now we will do this. First, you have to consider RHS to be equal to 0. This question is same as d square minus 3d plus 2 of y is equal to 0. Now, auxiliary equation is considered. So, what's the auxiliary equation? M square minus 3m plus 2 is equal to 0. So, solve for m, we will have 1 and 2, right? 1 and 2 are the roots for this. Therefore, your CF is C1 e power x, C2 e power 2x. Therefore, your U is e power x, B is e power 2x. So what about the Wronskian? U, B, U dash, B dash. So U is e power x, its derivative is e power x again, e power 2x, 2 e power 2x. To expand this, you will have 2 e power 3x, right? 2 e power 3x minus e power 3x. So we will have e power 3x is your Wronskian. Right? If you multiply this, I'm just adding the powers 2x plus 3x, 2x plus x, right? So e power 3x is your Wronskian. Now you find what is your PI? PI is u into f of x plus b into g of x. Now what is f of x? Minus integration of dr by w dx. So minus integration of what is b? B is e power 2x into w by w e power 3x. What is r? E power x by 1 plus e power x dx. Now you can see e power 2x, e power x, e power 3x will get cancelled, right? E power 2x into e power x is e power 3x. E power 3x divided by e power 3 will get cancelled. So we have minus of 1 by 1 plus e power x dx. So is f of x, f dash. No. So we have we don't have e power x here, right? Okay, so what we'll do is we'll multiply and divide by we'll multiply and divide by e power minus x. So we have minus integration of 1 by 1 plus e power x dx, right? Okay. What we can do is we will multiply and divide by e power minus x. It will be e power minus x. So if you multiply this e power minus x inside, you will what we will have? E power minus x into 1 is e power minus x. E power minus x into e power x will be 1, right? Now we can see f of x, f dash of x, right? Now you can see f of x, f dash of x after multiplying and dividing by e power minus x. This is log of e power minus x plus 1, right? F of x, f dash. Okay. Now you have to find g of x. G of x is integration of ur by w dx. Integration of u. What is u? U is e power x by w is e power 3x. R is e power x by 1 plus e power x dx, right? Now this is same as e power 2x by e power x. So we will have e power x into 1 plus e power x dx, which we already solved, right? So we already solved the previous problem. We know 1 by integration of 1 by e power x into 1 plus e power x. We already know solution. So I'm going to write directly. The solution is log of 1 plus e power x minus x minus e power minus x, right? So refer previous problem. See, we are going to see e power x, e power x, e power 2x. This e power 2x, here we have e power 3x, so we will have 1 e power x here. So e power x, here we will have 1 e power x, right? Okay. We already solved this. We already know the answer for this, right? Put e power x is equal to z and do partial fraction. You will get the answer. Right? So therefore, your PA is u into f of x plus b into g of x. So what is u? U is e power x. What is your f of x? Log of e power minus x plus 1. B is e power 2x. What is your g of x? G of x is log of 1 plus e power x minus e power, right? So therefore, the general solution is y is equal to cf plus pi. So add it up, cf and pi, right? Cf is the c1 e power s plus c2 e power minus. We move on to 8th problem. So solve d square y. See, I'm going to do this problem. The similar problem I'm going to do next problem. I'm going to give exercise 9th problem. D square by dx square minus 2 times dy by dx is equal to e power x sin x. See, you can solve this by previous problems. That is, this comes under a second order linear differential equation constant coefficient and type 4. Right? You can also solve by that method also, but I'm going to solve by variation of parameters. See, you can solve the same problem by type 4. This question is same as d square minus 2d of y is equal to e power x sin x. You can solve by type 4. So replace d by d plus 1. So this e power x work is completed now. Take that to the front side. So you will have 1 by d square minus 2d sin x. You can do by easily by type 4. But I'm going to solve this by variation of parameters. Right? I'm going to solve by variation of parameters. You can also use the previous method, that is type 4, to solve this problem. But if the question is saying that solve by variation of parameters, you have to do that. That is what I have said. This is a stochastic case. You can solve any problem by variation of parameters, right? So consider d square minus 2d of y is equal to 0. So that means your auxiliary equation is m square minus 2m is 0. So we take m outside, we will have m minus 2 is 0. So 0 and 2 are the roots. So therefore, your CF is C1 e power 0x, C2 e power 2x. So C1 into 1, C2 e power 2x. So therefore, your U is 1 and your V is e power 2x. And what about the Wronskian? U dash, V dash. So 1, 0, e power 2x, e power 2x into 2. So you'll have 2 e power 2x, right? 2 e power 2x is your Wronskian. Therefore, your PA is u into f of x plus b into g of x. So we know u and b. Now find f of x and g of x. So f of x is minus integration of dr by w dx minus integration of b into r. So what is b? b is e power 2x. R is e power x sin x divided by w. W is 2 times e power 2x, right? E power 2x will get cancelled. So we will have minus 1 by 2 integration of e power x sin x dx. E power x sin x dx. So you know this is a standard formula, right? Integration of e power ax sin bx. What is formula for this? Integration of e power ax. So it is e power ax by a square plus b square a sin dx minus b cos dx. This is a standard formula. And also integration of e power ax cos bx into d. So what is this formula? This formula is e power ax by a square plus b square. Sorry. Sorry. E power minus ax sin bx. What about this formula? See, all very standard formula, right? I have already given all the formulas when we are solving a Laplace transform, right? When we are doing problems on Laplace transform, I have already solved those problems. Just a minute. I think this formula is enough, right? After now we don't need other formulas, right? Let us keep this formula alone. So therefore here you put a is equal to 1, b is equal to 1. So we have e power x, a is 1, b is 1. Right, a is 1, b is 1 in the substitute here. So this will be 2. So we will have minus e power x by 4 sin x minus cos x. This is for f of x. G of x is integration of ur by w dx. What is u? U is 1. R is e power x sin x. W is 2 e power 2x. So this is 1 by 2 integration of e power minus x sin x, right? E power minus x sin x. So this is here a is equal to minus 1. A is equal to minus 1. Minus 1 sin x. B is 1. Right? Minus sin x minus cos x. So this will be, so if I take this minus outside, we will have minus e power minus x by 4 sin x plus cos x, right? So minus, I take this minus outside. This will be 2 minus 1 by 4 e power minus x sin x plus cos x. This is your g of x. Therefore, your PA is u into f of x plus b into g of x. General solution is y is equal to cf plus pa. See, we have to substitute u, and u is 1, f of x is this term, b is e power 2x, and g of x is this term, right? Substitute here. I'm not substituting. So, ninth problem is your exercise problem, right? Similar problem. The only thing is you have to know the formula for e power x cos bx. What is the formula for that? So, solve the exercise problem. Solve d square by dx square minus 2 into dy by dx is equal to e power x cos x. So same problem, instead of sin x we have cos x, right? So exercise problem, only thing is here you will be using the formula e power x cos bx, right? You will be using the formula e power x cos bx. So just a minute. E power x cos bx. Yes, I'll use the formula here. So here you will be using the formula integration of e power x cos bx, right? Here you have used this formula, right? This is e power x. Here we have plus, that's it. E power x by a square plus b square a cos bx plus b sin bx. Right? You have to use, here we have minus, here we have plus. That's the only difference for this, right? You'll be using this, right? You take this exercise. Okay. So we'll move on to the last problem in this class. Okay, if you want the answer is answer for this is c1 plus c2 e power 2x. This was cf minus 1 by 2 e power x. So after simplification, right, you cannot simplify this term. You multiply this inside, multiply this inside. After simplification, you will get this term as answer, right? Okay. You cannot simplify this term. You cannot simplify here, right? That is after multiplying b with g of x, right? After multiplying b with g of x and collect all the like terms, you will getting this answer, right? Here also your PA will be, that is after simplifying, that is all collect all the like term, you will have minus 1 by 2 e power x sin x. That is after multiplying u f of x plus b g of x some multiply u inside, multiply v inside, collect all the like terms, you will get minus 1 by 2 e power x sin x. That will be your partial integral for this problem. Here we have minus 1 by 2 e power x cos x, right? Okay. So we'll move on to the last problem this class, and then we'll continue 11th problem from the next class. We'll move on to the last problem in this class. So using method of variation of parameters, using method of variation of parameter, solve d square y by dx square minus 2 times dy by dx plus y is equal to x e power x sin x. You can solve without using variation of parameters also. You can solve this problem. This comes under type 5 or type 6, right? Replace d by d plus 1 and solve for x sin x. And for x sin x, you'll be using the formula 1 by f of d xv, right? Okay. Yeah, watch previous videos. You will know what I'm saying. With y of 0 is equal to 0 and dy by dx at x is equal to 0 is 0, right? So they have given these two data to find the value of arbitrary constants, right? So we'll do this very fast, right? Or a very easy problem. We'll do this fast. Okay. Can you note up to now? Okay. So consider y double dash minus 2y plus y is equal to 0. So your auxiliary equation is m square minus 2m plus 1 is equal to 0. So here we have 1 and 1 are the roots, right? This is m minus 1 whole square formula. So equal roots. So your CF is C1 plus C2x e power x. So you can write this as C1 e power x plus C2 x e power x. Therefore, your u is e power x, v is x e power x, right? V is x e power x. Okay. So v is x e power x. Now find the Wronskian. U, v, u dash, v dash. So u is e power x. Derivative is e power x again. X e power x derivative is x e power x plus e power x, right? Product rule. So x derivative e power x is e power x. E power x keep as it is. Derivative of x is 1. So if you multiply here, you will have x e power 2x plus e power 2x minus x e power 2x. So these two will get cancelled. So e power 2x is your Wronskian, right? Now you find the partial integral, which is u into f of x plus b into g of x. Your f of x is minus integration of er by w dx. So minus integration of v into r. So v is what? V is x e power x divided by w. So w is e power 2x. R is x e power x sin x dx, right? So e power x, e power x, e power 2x will get cancelled. So minus integration of x square sin x dx. So you have to integrate this, right? Use integration by parts or apply Bernoulli's theorem. So u v1 minus u dash v2 plus u double dash v3 and so on. So your u is x square, v is sin x, or you can also use integration by parts also, right? So u dash is 2x u double dash is 2. So you can stop up to u double dash. U triple dash will be 0, right? So your v1 is integrate this. So v1 is not. So for this will be minus cos x. v2 will be again integrate cos x. Cos x will be sin x. And what about v3? It is minus integration of sin x is minus cos x. Will be cos x, right? Now apply the formula u into v1. So u is x square. v1 is minus cos x minus u dash. U dash is 2x. v2 is minus sin x plus u double dash is 2. v3 is cos x. Right? You don't need to go on, right? You can stop up to u double dash because u triple dash and so on will be 0. So if I multiply minus, we will have minus will be plus. This will be x square cos x. Multiply this minus inside. Minus will be plus. Again we have minus here. So minus 2x sin x minus 2 cos x. So this is your f of x. Now find the g of x. G of x is integration of ur by w dx. Integration of u. What is u? U is e power x. V is e power 2x. R is x e power x sin x dx. So e power x, e power x, e power 2 will get cancelled. So integration of x sin x dx. So u into v1. So u into v1. So v1 is sin x integration is minus cos x minus u dash into v2. So v2 is, you have to integrate this cos x minus cos x once again, which is minus sin x. This will be plus sin x minus x cos x. Sin x minus x cos x is your g of x value. So therefore, your particular integral is u into f of x plus v into g of x. So u is e power x, and this is IS 2005. So f of x is e x square cos x minus 2x sin x 2 cos x plus b. B is x e power x sin x minus x cos x, right? Okay. Therefore, the general solution is y is equal to cf plus pi. So cf is c1 e power, what is that? C1 e power x, p2 x e power x plus pi is e power x x square cos x minus 2x sin x minus 2 cos x plus x e power x sin x minus x cos x. See, your problem is not yet over. We have to find the value of the arbitrary constants c1 and c2. Right? This is your solution y of x. Now it is given that y of 0 is 0. Right? Y of 0 is 0, right? Yes, y of 0 is 0. So if we do that, we will have 0 is equal to, because y of 0 is 0, we put x equal to 0, we will have c1 e power 0 is 1. This will be 0, right? It will be 0. And here we will have e power 0 is 1. This will be 0. This will be 0. 2 times cos 0 is 1. And this will be 0, right? Because 0 into anything is 0. So you will have 0 is equal to c1 minus 2, right? 0, 0, minus 2. This implies the value of c1 is 2. Now use the second condition that y dash of 0 is 0, right? Y dash of 0 is 0. Now for that you have to differentiate this y dash of x, right? Very simple, right? You can do, right? So find y dash of x. In that you put x is equal to 0, you will get c2 to be equal to 0, right? 2 by yours. If you differentiate this term and put x is equal to 0, you will have c2 to be equal to 0, right? Okay, so therefore, the general solution is so C1 is 2, therefore y of x is 2 e power x, C2 is 0, so I'm going to cancel this term. We will have this to be e power x into square cos x minus 2x sin x minus 2 cos x plus x e power x sin x minus x cos x. That's it, right? This is the required solution. So we'll stop here. So we have solved 10 problems in this class. Okay, we have solved 10 problems in this class. We have introduced method of variation of parameters, right? Very, very easy problem. The conclusion is whatever this R may be, we can solve by variation of parameters, right? In the previous cases, we will restrict, right? Type 1, type 2, type 3, type 4, type 5. But here, whatever artist may be, you can solve by variation of parameters, right? Yes. So, next class will continue from 11th problem, right? So, thank you. This is the next class. All the best.